Is my voice is clear and screen is visible to you all? Okay. So in last lecture, we have completed our previous chapter. That is just how we can do our task parallelly. We have learned parallel methods. How many methods are there? So we have seen that how to solve our problem in parallelly using parallel methods. Parallel methods. We have seen 8 parallel methods, and we have seen how task can be done if how task can be divided internally. If you want to do parallel processing, then first of all you have to check whether you can perform a particular, you can divide a particular job into subtask, and if you can divide it into subtask, can you perform subtasks simultaneously? So that can be checked using that graph. So that graph we have learned, dependency graph, intertask dependency graph we have learned in our previous chapter. And now we are going to learn the pipelining. So that is a method number 1, which we have learned in our previous chapter. That is a pipelining, or you can say that temporal parallelism. So how we will achieve temporal parallelism in our computer, how we are performing, how we are implementing this temporal parallelism, this pipelining in our computer system. So at the instruction level, so chapter name is instruction level parallel processing. So instruction level parallel processing. So we are going to implement our temporal parallelism technique, or you can say pipelining, for our program, for instructions. But before we are going to discuss it, we are going to discuss some basic things about this pipelining. So pipelining, this is just introduction to this pipelining. What is the pipelining and what are the problems in pipelining? So pipelining, what is a pipelining? So as we are already aware about it, it is our method 1, that is a temporal parallelism. What we are doing, हम यहाँ पे क्या करेंगे, if we are talking it in terms of instruction now. So if we will talk it in terms of instruction, so what we will do over here, we will consider that we are having more than one processing element. यहाँ पे ये टर्मिनोलॉजी हम फ्रीक्वेंटली यूज करेंगे पीई. सो पीई का मीनिंग क्या होगा? व्हाट इज द मीनिंग ऑफ पीई? पीई मींस प्रोसेसिंग एलिमेंट. सो वी आर हैविंग more than one processing element for parallel processor. But pipelining can be implemented only if you are having only one processing element. आपके पास एक ही processing element है, फिर भी आप pipelining implement कर सकते हो. क्यों? क्योंकि आपकी जो instructions है उसके execute करने के लिए आप उसको divide कर सकते हो. You can divide your instruction into some subtask. So we are doing the same thing over here. We will do first, we will divide our instruction into subtask. So that is, you are already aware about it. You already learn it into CO stages of pipelining, instruction fetch, instruction decode, instruction execution, memory storage. So that it depends how many stages are there. According to that, we will design it. So don't worry, we will discuss it in detail over here. So we will discuss about the pipelining. So pipelining is nothing, it is an effective method of increasing the speed of processor. सिंगल प्रोसेसर और मोर देन वन प्रोसेसर. आप एक प्रोसेसर के लिए भी पाइपलाइनिंग इंप्लीमेंट कर सकते हो और मल्टी प्रोसेसर के लिए भी पाइपलाइनिंग इंप्लीमेंट कर सकते हो, provided that following conditions should be satisfied. So ये condition उसमें satisfy होनी चाहिए. आप pipelining कब implement कर सकते हो? So if these conditions, 4 conditions will be satisfied, then you can say that we can implement pipeline. So what is the first condition? That it should be possible to break up your instruction into number of independent parts, and each parts should be take near about equal time. So अगर आप ऐसे आपकी instruction को divide कर सकते हो in different 3 phase 4 phase, आप उसको different phase में divide कर सकते हो. और phases का timing भी क्या होना चाहिए? आपके जो आप जो part में सब part में divide करोगे, independent part में divide करोगे, वो part का execution का time क्या होना चाहिए? It should take same amount of time. Suppose मैं आपको बताता हूँ. Suppose let's take example that instruction, we are going to execute an instruction. So instruction को एग्जीक्यूट करने के लिए आपको पहले क्या करना पड़ेगा? यू हैव टू फर्स्ट ऑफ ऑल फेच द इंस्ट्रक्शन from your secondary storage device to the main memory. So that is called fetching of instruction. Then second step, decoding of instruction. That what is a instruction, what is a opcode in instruction, how many operands are there in instruction, what is that operand. So that is called decoding of instruction. So that is a stage number 2. Same way, once the opcode is decided, you have to identify that whether it is a memory related instruction, whether it is a branch related instruction. So based on that, we will perform next task. So that is a execution of instruction, step number 3. And once the instruction will be executed, whatever result of that instruction, that we need to store somewhere. So that is how you can say that 4 step. So instruction जो हम एग्जीक्यूट करेंगे, हमारा प्रोग्राम एग्जीक्यूट करेंगे, उसमें जो एक इंस्ट्रक्शन एग्जीक्यूट करेंगे, we will divide it into this 4 stages. This is just one example that you can divide it into 4 stages. So if we can be, and that 4 stages should take equal time. आपका जो इंस्ट्रक्शन फेच करने का टाइम है, इंस्ट्रक्शन डिकोड करने का टाइम है, इंस्ट्रक्शन एग्जीक्यूशन का टाइम है, वो सेम होना चाहिए. So that is a false assumption. So there is an locality in instruction execution. By this we mean that the instructions are executed in sequence one after another in the order in which they are written. It means that suppose ये आपका प्रोग्राम है, तो आपके प्रोग्राम में पाइपलाइनिंग जो आप इंप्लीमेंट करोगे वो एडवांटेज कब देगा, व्हेन इट विल प्रोवाइड एडवांटेज. सो if you are having sequential instruction means 1 2 3 4 5. If you are having such instructions, and these instructions, suppose n number of instructions you are having, and it should be executed in sequence. पहले instruction execute होनी चाहिए, फिर second, then third instruction, फिर fourth instruction, like that. So it should be executed like this. अगर इसमें आपके पास jump instruction होगी बीच में, jump to particular, let's say that location 100. So if you are having more jump type instruction, or you can say that control transfer instruction, jump वाली instruction को कौन से type की instruction बोलते हैं, in which you need to transfer your program control. So if the jump, call, return, if such more instructions are there in your program, then pipelining will not give you better result. So pipelining implement करने के लिए following conditions satisfy होनी चाहिए. उसमें से second condition क्या है, locality in instruction execution. It means that there should be less number of jump, or you can say that program control transfer instructions. So if jump instruction is there, then this particular method will be not that much effective. Same way, successive instructions are such that work done during the execution of your previous instruction can be used by the next instruction successive, and this successive instructions should be independent of each other. दोनों instruction आप separately execute कर पाने चाहिए. First instruction as well as second instruction, both should be not dependent on each other. If they are dependent, then there will be the problem in pipelining. So we will discuss all this kind of problem also. वो problems क्या आएंगे, कैसे आएंगे, सब कुछ हम discuss करेंगे. But this is ideal condition. अगर ऐसा नहीं है, दोनों instruction independent है, then pipelining will give you the better result. And same way, you should have enough resources. Enough resources means आपको pipelining, आपको instruction fetch करनी है, instruction decode करनी है, instruction execute करनी है, memory access करनी है. So you should have enough number of resources at a time. Suppose you are going to execute 2 instructions, so you should have 2 processing elements. Suppose you are going, 2 instructions are going to access a memory, so you should have 2 paths to access the memory. So that kind of enough resources should have, then pipelining will give you the better result. So this ideal conditions, if they are satisfied, then pipelining will be implemented in better way. And these are the non-identical situation. It means that these are the problems. These are the problems arise while you're pipelining, or you can say that these are the problems due to which you can not implement pipelining very efficiently. So that is, it is not possible to break up an instruction execution into a number of tasks, each taking exactly same time. So अगर आप आपकी instruction को, आप जो instruction के steps है, fetch instruction, decode instruction, वो अगर same time नहीं लेते, each and every instruction, each and every phase is taking different time, then this pipelining will not give you the better result. So in that case, pipelining is not the best option. So that is a non-identical situation, you can say that. So this is a non-identical situation in which it is not possible to break your instruction into number of sub parts such that each will take exactly same time. ऐसा आप नहीं कर सकते हो तो वो नॉन आइडेंटिकल सिचुएशन है. इसका मीनिंग यहाँ पे पाइपलाइनिंग आपको बेटर रिजल्ट नहीं प्रोवाइड करेगा. सेम वे जो जंप इंस्ट्रक्शन मैंने आपको प्रीवियस स्लाइड में बताई थी, सो यहाँ पे भी वही है. ऑल प्रोग्राम्स हैव ब्रांच इंस्ट्रक्शंस. जनरली हमारी प्रोग्राम्स जो प्रोग्राम्स हम लिख रहे होते हैं, सो इन आवर प्रोग्राम्स वी आर हैविंग सच ब्रांच इंस्ट्रक्शंस, कॉल इंस्ट्रक्शंस, जंप इंस्ट्रक्शंस, सो दैट इट विल चेंज सीक्वेंस ऑफ योर सीक्वेंशियल एग्जीक्यूशन. इसका मीनिंग क्या है? वो पहली इंस्ट्रक्शन, दूसरी इंस्ट्रक्शन, थर्ड इंस्ट्रक्शंस, नॉर्मली इसके बाद फोर्थ इंस्ट्रक्शन आनी चाहिए, बट सपोज योर थर्ड इंस्ट्रक्शन इज जंप इंस्ट्रक्शन, so it will affect your pipelining. So jump to XYZ location, XYZ location पे जाएंगे हम, so XYZ location से अब instruction execute करने हैं. So it means that in this kind of scenario, it will affect your pipelining. Pipelining को affect करेगा. This is non-identical situation for pipelining. So statistical analysis says that probability of branch instruction is very low in your program, and around 17% instructions can be branch related instructions. And even if this kind of branch related instructions are there, then also we can solve this kind of problem by predicting this branch. What will the branch? Suppose यहाँ पे conditional branch है. Suppose मैंने यहाँ पे लिखा है jump if positive. So we can predict it in advance whether the result will be positive or negative. So don't worry about it. We will learn it how we can predict it. कैसे predict करेंगे. So by predicting it, we can achieve better pipelining. But if this kind of jump instruction are there in your program, then that is a non-identical situation. So all these 4 points, you can say that all 4 points are known as problems in pipelining. ये slides का heading में क्या और क्या दे सकता हूँ? What is another heading I can give it? So problems in pipelining. How many problems are there? How you can say that? What are the problems that you can face in pipelining to implement pipelining? If this kind of situation is there, then you can having a problem to implement the pipeline. And same way, successive instructions are not always independent. In that case, also pipelining cannot be efficient. If two instructions are dependent on each other. Suppose यहाँ पे मैंने लिखा हुआ है add. First method is add R1, R2, R3. We will see which example, lots of examples हम यहाँ पे study करेंगे. Suppose ये instruction है, तो इसमें हमारा result कहाँ पे store हो रहा है? So our result is storing in R1 register. And same way, in next instruction itself, we are directly taking this R1 here as one of the source. Perform subtraction between R5 and R1 and store result in R6. So this kind of two consecutive instructions will be there. Then also it will lead to data problem because यहाँ पे R1 का result आपका ready नहीं होगा. So you cannot start this second instruction जब तक ये आप ये instruction complete नहीं कर सकते हो, आपका pipelining आप start नहीं कर सकते हो. So these are the problems. Successive instructions, if they are not always independent, then also pipelining will be having a problem. And there are always resource constraint in a processor as there is a limited chip size. So we are having a resource constraint. That's why we are having this pipelining. We cannot implement the pipeline efficiently. Don't worry about these two slides first of all right now. This is just introduction that what are the problems in pipelining and how what is a pipelining. We will see with examples you can get better idea. हम एक एग्जांपल देखेंगे, उसका sequential execution क्या होगा, उसका pipelining execution क्या होगा, that I will explain you so you will get better idea. So we will take one example over here. So for which kind of system we are going to implement it right now? So we have considered one of the system. कौन सी सिस्टम के लिए हम ये पाइपलाइनिंग अभी इंप्लीमेंट करने वाले हैं? सो दैट इज अ सिस्टम नेम, दैट इज अ SMEC2 PC. सो SMEC2 आर्किटेक्चर्स, आपका जो एक कंप्यूटर है उसका नाम है दैट इज अ SMEC2. सो SMEC इज वन ऑफ द कंप्यूटर सिस्टम डिजाइन बाय Raja Raman and Radhakrishnan. SMEC2 is a computer name, and we are considering right now one of the hypothetical processor, hypothetical computer. So it is not exist in real, but just for our theoretical purpose, for understanding purpose, we are considering it over here. So that is, we have given that name over here, SMEC2. P means our hypothetical processor. So this is SMEC2 PC. SMEC2 is a real processor. SMEC2 is a real processor or real system which is exist and designed by Rajaraman and Radhakrishnan. But SMEC2P is not a real, it is hypothetical computer in which we are having this following characteristics. So this is the characteristics, this is a, you can say that architecture of our hypothetical processor, hypothetical computer. So in this hypothetical computer, we have implemented RISC architecture. So RISC hypothetical computer is there. What is the meaning of RISC now? RISC means reduce instruction set of computer. It means that this particular computer will have very limited number of instruction set, very limited number of, that is, you can say that operand, very limited number of instruction set. The memory access is very limited to two instruction only, load and store instruction. How many ways are there to calculate the effective address? So we will have very less number of effective address calculations are there. So all these things are the property. You are already aware about the properties of RISC. RISC की properties आप सभी को पता है. RISC means reduce instruction. So we will have only limited number of instructions are there. Okay. So this is a RISC architecture, RISC computer system, in which we are using two memory. One memory we are using for data and second memory we are using for instruction. So there are two cache memory. One memory that is a data memory, data cache, and second memory that is a instruction cache. Instruction will be fetch or instruction will be read from this instruction cache and data will be read from this data cache. हम data कहाँ से access करेंगे? Data memory में से. And instruction कहाँ से access करेंगे? Instruction cache में से. Next, these are the characteristics. Next characteristics, memory address registers. So हमारे पास जो दो memory है, this is first memory that is for, let's say that this is for instruction. So उसको हम बोलेंगे I memory, and this is, let's say that for data. So this is, let's say that it is called data memory. So currently कौन सी instruction execute होगी? Currently कौन सी instruction आप execute करने वाले हो? कौन सा address memory में आप access करने वाले हो? So that will be stored in one of the register that is called memory address register. And it is related for instruction. So that is called instruction memory address register. So I memory, IMAR. So that is instruction memory address register. Same way, data जो भी आपने memory में store किया होगा, उसका भी कुछ address होगा. So that address you will get it from data memory address register, DMAR. So that is called data memory address register. Okay. Next, right now we are just getting we are getting familiarization with our terminology, basic terminology. We will use this old terminology, these registers in our instruction pipelining. Okay, then instruction, ये particular memory जो हमारी select होगी, वहां से instructions fetch होके कहाँ पे store होगी, कौन से register में आएगी? That register name is instruction register. From that particular memory, instruction will be fetched and stored into instruction register. And same way, यहाँ पे जो data होगा, ये जो address पे जो data होगा, वो हम कहाँ पे store करेंगे? So that is known as data register, and that is called memory data register, MDR. So we are calling it this register as a MDR, and this is called instruction register only. So it will indicate instruction register में क्या आएगी? Instruction आपकी आएगी. And data register में क्या आएगा? Data, your data from the selected address. Already we are familiar with program counter. Program counter is nothing but it stores the address of your next instruction. कौन सी instruction next execute होने वाली है, वो यहाँ पे आपको program counter बताएगा. So that is a program counter will point to the next instruction address. Machine word. So यहाँ पे आपका जो instruction होगी, यहाँ पे जो operation होगा, वो हम word addressable operation perform करेंगे. So word addressable means what? At a time 32-bit data we will operate on at a time 32-bit data. So SMEC2 PC, SMEC2P is our word addressable machine in which you can operate 32-bit data at a time. It means what? यहाँ से जो आप मेमोरी में से डेटा रीड करोगे, so whatever data you will read, it is from instruction memory or from data memory. So at a time you will read 32-bit. 32-bit का डेटा यहाँ से आपका रीड होगा इंस्ट्रक्शन मेमोरी में से या डेटा मेमोरी में से. So that is a 32-bit registers, 32-bit operation. And how many registers are there in this our SMEC2P architecture? SMEC2PC में कितने हमारे पास registers है? So we are having registers number R0 to register number R31. And each and every register is of size 32-bit. हर एक register की size भी क्या है? 32-bit. Each and every register is of size 32-bit. So how many such registers are there? Total 32 registers are there. Number from R0 to R31. So general purpose registers, or you can say that you can use a register as a to store your data, temporary data, to store your index. कुछ भी store करने के लिए हम ये register का use कर सकते हैं. So we will have register file. 32 registers are there, and instructions are of all instructions are of equal length, and relative positions of operand are fixed. आपकी ऑपरेंड इंस्ट्रक्शन में कहाँ पे होगा उसकी पोजीशन भी फिक्स होगी, आपकी इंस्ट्रक्शन की लेंथ भी है वो भी फिक्स होगी. सो दिस इज अबाउट द इंस्ट्रक्शन. इंस्ट्रक्शन कौन सा टाइप की हम यूज करेंगे यहाँ पे? सो वी विल हैव ओनली लिमिटेड नंबर ऑफ इंस्ट्रक्शंस एंड कैटेगरी ऑफ दिस इंस्ट्रक्शंस ओनली 3 कैटेगरी. That is a register type instruction, memory type instruction, and jump type instruction. And what will be the format of instruction? Instruction का format क्या होगा? ये जो हमारा जो architecture हम यहाँ पे use करने वाले, जो PC use करने वाले हैं, उसका format, instruction का format क्या है? So if it is a read type, if it is a register type instruction, अगर वो register type instruction होगी तो bit number 25 to bit number 31. Sorry, bit number 26 to bit number 31. So how many bits are there? 26, 27, 28, 29, 30, 31. So 6 bit. 6 bit we are using for opcode. If you will observe, for each type instruction, how many bit we are using as a opcode? Opcode के लिए आप कितने bit use कर रहे हो? So 26 to 30. यहाँ पे भी 26 to 31. 26 to 31. So total 6 bit we are using for instruction opcode. So if you are using 6 bit for opcode, so how many different instructions you can specify using this 6 bit? If 6 bits are there as an opcode you are mentioning, so how many different total number of instructions can be possible? Yes, 2 raised to 6. So 2 raised to 6 means 64. So we can have 64 number of instructions for our SMEC2 PC. So as I already told you, this is having very limited number of instructions. This particular processor, this particular machine is having very limited number of instructions. So only 64 instructions are there, and that कौन सी instruction होगी वो कहाँ से decide होगी? It will be decided based on the opcode. Okay, next, अगर वो register type की instruction होगी, register type की instruction means what? Suppose आपने instruction लिखी है move data from R1, तो उसका format क्या होगा? Move instruction अगर आपको register type की instruction लिखनी है तो उसका format क्या होगा? What will be the format? So जिसमें आपके operands होंगे वो सिर्फ register ही होंगे. Your operands will be only registers. So यहाँ पे हम 3 operand mention कर सकते हैं, operand number 1, operand number 2, and operand number 3. In previous slide, we have seen that how many total registers are there? Total 32. It means that total R0 to R31. So अगर इसमें से कोई एक register आपको ये register set mention करना होगा, तो आप कितने bit use कर सकते हो? कितने bit का use करके 32 register आप mention कर सकते हो? कितने बिट यूज करके आप 32 रजिस्टर को इंडिकेट कर सकते हो? 2 raised to 5, so 5 bit. 32 means 2 raised to 5, so 5 bit, only 5 bit will require. So आपका कोई ऑपरेंड आपको यहाँ पे मेंशन करना है R1, तो आपको कितने बिट यूज करने होंगे? 5 बिट. सपोज आपको यहाँ पे आपका ऑपरेंड मेंशन करना है, यू वांट टू mention your operand 1 as a R1, you want to mention your operand 2 as a R2, and you want to mention operand 3 as a. So if you want to mention any operand, then you require just 5 bit. So these are the 5 bit: 21, 22, 23, 24, and 25. These are the 5 bit for operand 1. Same way, 16, 17, 18, 19, and 20. These are the 5 bit for operand 2. And same way, 11, 12, 13, 14, 15. This is for operand 3. And these bits are not used. अगर आपकी इंस्ट्रक्शन रजिस्टर टाइप इंस्ट्रक्शन है, if your instruction is register type instruction, then this bits 0 to 10 are not used. ये बिट हम यूज नहीं करेंगे. Only use bits are this operand 3, 11 to 16, 11 to 15, then 16 to 20, 21 to 25. Okay, which will indicate your R1, R2, R3. यहाँ पे ये R1 indicate, or you can say that which will indicate your operand 1, operand 2, operand 3. आप यहाँ पे suppose mention करना चाहते हैं R16. So according to that you have to mention 16 का, आपको 16 mention करना है तो 5 bit में आपको 16 को represent करना होगा. Suppose you want to mention R8, so आपको यहाँ पे 8 को 5 bit पे represent करना, जिस follow करेगी. It might be possible that your suppose if your instruction is jump instruction, तो उसमें ये execution और memory access आएगा ही नहीं. वो पहले instruction fetch होगी, decode होगी, और decode होगी आपको पता चलेगा कि this is a jump instruction. So it don't require any other thing. It will directly just store your address into program counter, and then it requires just only 2 stages. In some instruction, it requires all 5 stages. Suppose if it is a conditional jump instruction, then it requires 3 stages. So we will see all the things. We will see both 5 stages चाहिए, 2 stages चाहिए, कैसे चाहिए, कौन से stage में क्या operation perform होगा. But this is just for starting point overview that 5 stage instruction pipeline we are going to use. पहले stage में हम क्या करेंगे? Instruction को fetch करेंगे, फिर instruction को decode करेंगे, instruction execute करेंगे, memory access, and then store. So now consider that there is one program. In this program, we are having such instruction. Instruction number 1, instruction number 2, instruction number 100. So एक हमारा जो प्रोग्राम है, this is our program, you can say that program number 1. और वो प्रोग्राम है, उसमें हमारे पास 100 ऐसी इंस्ट्रक्शन है. So if we will do sequential execution of our program, तो इसका मीनिंग, इसको आप किसके साथ कंपेयर कर सकते हो? If you are using only one teacher to evaluate your answer book, आपकी आंसर बुक है, उसमें सपोज अभी ये जो एग्जांपल है उसके साथ आपको मैप करना है, तो आपकी एक आंसर बुक में 100 आंसर्स है, और ऐसे आपके पास बहुत सारे स्टूडेंट्स हैं. Let's say that 5,000 students are there, 10,000 students are there. So how to do this? If you will do it sequentially, एक ही टीचर रखोगे आप, तो वो टीचर क्या करेगा? फेच इंस्ट्रक्शन करेगा, डिकोड इंस्ट्रक्शन करेगा, एग्जीक्यूट करेगा, मेमोरी एक्सेस करेगा. So everything will be done by only one element, by one teacher. So for यहाँ पे आपकी पहली इंस्ट्रक्शन कंप्लीट होगी. Now suppose consider the time. Ideal time 1 minute for all, 1 minute for each stage. So इसका मीनिंग क्या होगा? आपकी फर्स्ट इंस्ट्रक्शन कब कंप्लीट होगी सीक्वेंशियल टाइम में? At the end of 5 minutes, your I1 means instruction number 1 will be completed. Same way, at the end of 10 minutes, your I2 will be completed. So suppose if there are 100 instructions, so how many time it will require? If there are such 100 instructions, so in sequential time, what is the time required in sequential? For executing one instruction, if it is taking 5 minutes. 1 मिनट आपकी फेच इंस्ट्रक्शन के लिए, दूसरे मिनट डिकोड के लिए, तीसरे मिनट एग्जीक्यूट के लिए, 4th minute is for memory access, and 5th minute for store result. So वो सिर्फ एक इंस्ट्रक्शन के लिए आपको 5 मिनट लगेंगे. Same way, this is for second instruction. So how many such instructions are there? 100 instructions are there. So it will take 100 into 5. So if it is a sequential, then it is taking 500 minutes. So अगर आप sequential में ये instruction execute करोगे तो वो क्या करेगा? 500 minutes आपको लगेगी. But what we will do over here, we will not use sequential, we will implement pipelining. So pipelining का meaning क्या होगा? आप ये task individual element को provide कर दोगे. So fetch instruction will be done by one unit, decode instruction will be done by another unit, execution instruction will be done by another unit, memory access will be done by another unit, and store result will be done by another unit. So हम यहाँ पे separate unit को ये task assign कर देंगे. So इसका मीनिंग हम 5 फैकल्टी रखेंगे. पहला फैकल्टी फेच इंस्ट्रक्शन करेगा, दूसरा फैकल्टी डिकोड करेगा, तीसरा फैकल्टी एग्जीक्यूट करेगा, फोर्थ फैकल्टी विल एक्सेस मेमोरी एंड फिफ्थ फैकल्टी विल स्टोर द रिजल्ट. अगर आप प्रोसेसर के बारे में बात करोगे तो यहाँ पे एक ही प्रोसेसर है हमारे पास और वो यहाँ पे चाहिए. प्रोसेसिंग एलिमेंट कौन सा है? सिर्फ ओनली वन, विच इज रिक्वायर ओनली एट द टाइम ऑफ एग्जीक्यूशन. क्योंकि प्रोसेसिंग एलिमेंट में क्या आएगा आपका? ALU. तो हमारे पास ALU तो एक ही है. हम यहाँ पे एग्जीक्यूट एरिथमेटिकल लॉजिकल यूनिट कब चाहिए? जब आपको इंस्ट्रक्शन एग्जीक्यूट करनी हो तब. बाकी के टास्क कौन परफॉर्म कर सकता है? सो इट कैन बी परफॉर्म बाय अदर यूनिट्स. सो ओनली वी कैन से दैट ओनली वी आर हैविंग ओनली वन ALU ओवर हियर, बट अदर यूनिट्स आर देयर विच विल परफॉर्म अदर टास्क. दूसरे यूनिट्स होंगे जो ये बाकी सारे टास्क परफॉर्म करेंगे. Fetch instruction unit is there which will perform fetching task, decoding. So ये आपकी पहली instruction के लिए. So this is my first instruction. So now once this instruction will be fetched, ये मैं suppose आपको यहाँ पे timing बताऊंगा. So this is 1 2 3 4 5 minute, 6 7 8 9, and let's say that this is my instruction number 1, instruction number 2, and instruction number 4. These are the 4 instructions. Right now, just consider as an example. So, अगर ये पहली instruction first minute पे कहाँ पे होगी? Fetch stage में. And second minute पे वो कहाँ पे होगी? Decoding stage में. So, at this second minute, at this minute 2, your fetching unit will be free. So, it will start fetching your next instruction. So, यहाँ से आपकी next instruction fetch होना start हो जाएगी. Same way, when your first instruction will go for execution, your second instruction will go for the decoding, and your third instruction will be fetch. So at this, you can say that time equal to third minute, 3 operations are going on simultaneously. Same way, at the fourth minute, what will happen? Fourth minute पे क्या होगा? आपकी जो पहली instruction होगी वो कौन से stage में होगी? मेमोरी स्टेज में, मेमोरी एक्सेस स्टेज में. आपकी दूसरी इंस्ट्रक्शन होगी वो कौन से स्टेज में होगी? एग्जीक्यूशन में. दिस इज नेक्स्ट इंस्ट्रक्शन. थर्ड इंस्ट्रक्शन इज देयर इन डिकोडिंग फेज, एंड देन योर फोर्थ इंस्ट्रक्शन विल बी देयर इन फेच इंस्ट्रक्शन. सो वन बाय वन आपकी इंस्ट्रक्शन ऐसे कंप्लीट होती जाएगी, फेच होती जाएगी. सो यहाँ पे अगर आप ऑब्जर्व करोगे तो पहले ये इंस्ट्रक्शन फेच हो गई, then this instruction is fetched, this instruction is fetched, so your instruction will be fetched over here. Then decoded, instruction आपकी decode होती जाएगी. Then instruction will be executed, instruction आपकी execute हो रही होगी. So like this. So this is a pipelining. This is, you can say that pipelining. Your instruction is executing in pipelining. Simultaneously, suppose आप ये particular moment पे बात करोगे, suppose 1 2 3 4 and 5. So at this particular moment, you can say that your first instruction is there in store result phase. The second instruction is in this phase. Your third instruction is in execution phase. Your fourth instruction is in decoding phase. Your next instruction, fifth instruction, will be in fetch phase. So like this. So ऐसे आपकी instructions simultaneously. Now at the end of 6 minute, what will happen? 6 minute के end में क्या होगा? आपकी पहली instruction complete हो जाएगी. So this instruction will be completed. Okay, and this instruction is there in your store result phase. this instruction is there in memory. So like this. So if you will observe, so only first instruction will take 5 minutes. पहली इंस्ट्रक्शन यहाँ पे आपकी जो होगी वो आपकी कंप्लीट होने में कितना टाइम लगेगा? इफ यू विल कंसीडर दिस टाइमिंग 1 2 3 4 and 5. So first instruction will be completed at the end of 5th minute. When your second instruction will be completed, आपकी ये second instruction कब complete हो जाएगी? I2. When it will be completed? It will be completed at 6 minute. I2 will be completed over here. Same way, I3 will be completed over here. Same way, I4 will be completed over here. So that is 7, 8, 9 like that. So it means what? That only first instruction will take 5 minutes. Remaining instruction will be completed in 1 minute. बाकी की जो instruction है, after that your each and every instruction will be completed in 1 minute. वो start क्योंकि वो already pipelining में आप execute कर रहे हो तो already पहले start हो चुकी होगी. So it means that for first instruction it will take 5 minutes, and for remaining n-1 instruction, how much time it will require over here? यहाँ पे उसको कितना time लगेगा? So that is only 1. So 5 in. So यहाँ पे हम जब भी पाइपलाइनिंग का टाइम हमने प्रीवियस भी कंसीडर किया था तो क्या किया था? 5 into 1 plus n-1. So suppose n equal to कंसीडर हमारा 100 है तो यहाँ पे 99 into 1. So ये हो जाएगा आपका पाइपलाइनिंग टाइम. If we will consider that each or every instruction in each and every stage is taking 1 minute only, then this is the example for pipeline execution. Is it clear? यहाँ पे कोई डाउट है? So in next lecture we will see what is each and every step, what we will do in each and every step. Step number 1 में क्या करेंगे, step number 2 में क्या करेंगे, step number 3 में क्या करेंगे. So ये जो step number 1 2 3 4 5 आपकी instruction कैसे पूरी execute होगी step by step. So this diagram we will see one by one. So पहले step 1 study करेंगे, फिर step 2 करेंगे, फिर step 3, फिर step 4 and step 5. So if you want to understand it very carefully, don't mix the next lecture. It is little bit important because based on that there will be examples, numeric examples can be there. इसके बेस पे अगर आपको ये पता चल जाएगा कि इंस्ट्रक्शंस कौन सी इंस्ट्रक्शन में कितने स्टेजेस यूज होते हैं तो आपको मैथमेटिकल कैलकुलेशंस में वो बहुत ज्यादा इजी रहेगा. Okay, so this lecture is over right now. You can leave this meeting and you can go for the next lecture.